Take two. Okay, let's try this again. Let's go back to this one. All right. What's up, guys? First try. Welcome to Model Monday Live. What a crazy month it has been. Yes, I was driving through a tunnel. Lost my connection there for audio for a second. Todd knew it right away. So welcome. And I am super excited about today's episode. Today is Monday, June 27th, Model Monday Live. Another episode with the most amazing chat ever. And also the most amazing guest ever. So we got a double whammy for you guys today. So I'm excited. Welcome. What's up, Chris? How you doing? Welcome in the chat to Chris Castle. What's up, Gerben? How you doing? Thanks for tuning in. Great to see you in here again, champ. Really good to see you. Can't wait to see if you can defend your title. It's coming up soon for sure. All right, so with that, let's get into it here. Let's take a look at our setup. And today is Monday, June 27th. Can't believe how fast this month is going. It has been a crazy month, but excited to see what July is going to bring us as well, and the rest of summer. And I hope you guys are all enjoying your summer as best you can. And today we have a very special guest. We got Chris Smith. He's a GD&T expert, amongst other things, and we're going to introduce him in just a moment. But before we do, we'll just run through a quick introduction here, and we're going to do 3 CAD speed modeling challenges today. So we've got 3 challenges lined up for you guys today. What's up, Bjorn? Thanks for tuning in. Good to see you. Thanks a lot for joining us again this week. We do have a special guest today, and of course, we have the best chat ever. And I'd like to always remind people about this in the beginning of the episodes. Whatever you can do to help the channel, the biggest thing you can do right now is just continue to like and subscribe, and of course, get out there and share and reshare it. I gotta say, thank you so much to everyone that I've seen out there sharing my posts. Whenever I see you guys repost stuff, retweet stuff, I really appreciate it. So thank you so much for that. And whatever you can do to like, subscribe, share. One way that you can share this stuff is just grab a screenshot of some of the challenges and, post them on your social media. And just say, hey, do you guys have any ideas on how you would model something like this? And that's another good way to get the word out. Or you can even just share it like in your department. Just say, hey, here's a weekly modeling challenge. I just grabbed one of these from Toby's live stream, and let them know, that they can find more examples like this at the Model Monday replay playlist on the TooTallToby YouTube channel. Of course, I want to give a huge shout out to the guys over at SolidBox who are really helping make this season of Model Monday Live possible. At SolidBox, what they try to help you do is make sure that whenever you configure and purchase hardware, you have a great experience right away. There's nothing more frustrating than getting a new CAD system, getting all excited about it, loading up SolidWorks, and right away running into errors like this. Your system is running critically low on memory. That's never good when you just dropped, $3,000-$4,000 on a new CAD workstation. So what the team at SolidBox will help you do is not only configure the appropriate hardware for what you're trying to accomplish, like one of the configurations is called Engineering Desktop 2, one that I've definitely had my eye on recently. But they'll also go through and make tweaks to Windows and make tweaks to the BIOS to make sure that when you get that CAD workstation, it's ready to operate at the highest possible performance, optimized for an engineering CAD CAM user like yourself. And the reason the team at SolidBox is able to do this is because they're made up of professional CAD and CAM users. So they really know what to look out for when they're running the benchmarks. They really know how to make sure that as soon as you receive that workstation, you're just good to go. You just take it out of the box, start using SolidWorks or whatever program you're using, and it just works. So if you're in the market for some new hardware, if your team is looking to upgrade your hardware, be sure to check out mysolidbox.com. Let them know that Toby sent you, and they will definitely take care of you. So with that, let's get into the Model Monday Live CAD speed modeling challenges. I'm going to show you a 2D print, and I'm going to challenge you to turn that into a 3D model. And your job is going to be to calculate the mass of that 3D model and then enter that mass in the YouTube chat. If you're here for the first time, let us know. Feel free to let us know that you're here for the first time competing. We'll be sure to take care of you. We'll be sure to answer any questions you have. But basically, the basic rules are you can use any CAD package. I use SolidWorks mostly, actually starting to branch out and use a couple other CAD packages these days, but mainly I use SolidWorks. But if you're using something else, that's fine. As long as you can input density and output mass, you are good to go. You want to make sure you use the specified precision that's on the print, and the first correct answer in the chat will be declared the winner. And so what you're going to need to do on your CAD workstation is you're going to need to be able to specify a material density. There's basically 3 materials that we use here. So what you do is you take your material library, make sure that your plain carbon steel has a density of 7,800 kilograms per cubic meter. If it doesn't, maybe you need to create a new material. Call it TTT plain carbon steel, TTT 1060 aluminum, TTT ABS, and just make sure that your materials in your library have the correct density that we use every week here in these challenges. If you don't have these, if you're here for the first time, maybe take a quick screen grab so that you can get these densities loaded into your material libraries. Also, each print will either specify that it's in IPS, inch, pound, seconds, or MMGS, millimeters, grams, and seconds. I think that's pretty much it for the basic rules. As far as the advanced rules go, this is meant to be fun and good-spirited. This is all just for your practice, give you guys a chance to get out there and use the CAD system of your choice. But along the way, I'll probably make a mistake here and there, and if I do, we'll just call an audible. The most common mistake that I make is I model the part symmetric. I model it from the origin, and then maybe downstream it stops being symmetric, and I forget to specify the offsets are centered. I'm just explaining that because if it looks like something is supposed to be centered, it probably is. I'm not trying to throw anything really tricky at you with regards to the nuances of dimensions or anything like that. And of course, the Ivan exploit is both permitted and sometimes even encouraged. So looks like Nico is here for the first time. Welcome, Nico. Welcome, welcome, welcome. I hope that you are going to be able to get in there and get through this model fast today. It's great to have you in here. It's great to have anybody in here who is new, who's here for the first time. So welcome, welcome. I see a couple more people came in. Milton is here. MD Shelby is here. Let's see here. And Rohit is here. Welcome, welcome, one and all. So with all this being said, let me flip over to my full screen here. And what I'm going to do is I'm going to show you a 2D print here. And when I do, your first task is going to be to grab a screen capture of that print. So get your screen capture software ready, whether it's Snagit or Windows Snipping Tool or MW Snap. And we are going to go live with this challenge in 3, 2, 1, go. So grab a screen capture of this print because I'm not going to leave it up for very long. This is your first challenge. This is a sync knob. Pretty obvious, I think, what that means. I'm looking for the answer here in grams. So xx.xx grams. So 4 significant digits, 2 before the decimal place and 2 after. This is going to be in millimeters, grams, seconds. The material is ABS, which has a density of 1020 kilograms per cubic meter. So go ahead and take a screen capture of this. I'm only going to leave this up for as long as it takes for me to take a sip of my tasty beverage here. I know you guys couldn't see me sipping it, but you're going to hear me burp in a second because it's quite carbonated. And hopefully that was enough time for you to grab a screen capture, maybe move that over onto your second monitor. That's what I do when I'm doing these challenges, and see what you can come up with. What is the mass of this part in xx.xx grams? Okay, I'm going to take that off of a full screen here. Now we've got a very special guest. I am super excited. This guest is a certified SOLIDWORKS expert. He's a hardware expert. He's a GD&T specialist. I want you guys to give it up in the chat. Put a 1 in the chat if you have a second, if you're not doing the challenge. If you're doing the challenge, you can get the 1 in the chat later. But if you guys don't know, putting a 1 in the chat is basically the equivocal of like applauding when no one can hear your actual clapping. So put a 1 in the chat here for none other than Chris Smith. Chris, how are you doing? Welcome to the show.
Hey, thanks for having me, Toby. I'm doing great.
Great. Well, as always, I'm going to be relying on the chat to let me know if anything sounds out of line, if Chris's volume is too low, if my volume's too high, or vice versa. If anything is problematic, let us know. I see all the ones rolling in the chat here, so guys are stopping doing their modeling challenge so that they can give you a round of applause. So
nice. I appreciate it.
Yeah, thank you so much for being on the show. This is so awesome to have you on here. I'm very excited.
Yeah, thanks for having me.
So what do you do? That's probably a good place to start, right? Who are you? What do you
do? Yeah. So I'm Chris Smith. I work for SolidBox, and I do a little bit of everything at SolidBox. I started with SolidBox in 2016 as just kind of a utility player. I did customer service, tech support, sold computers, and I took kind of a roundabout route to CAD. So I have a journalism degree, and I actually then worked in e-commerce for years, but joined SolidBox in 2016 because Chris Castle, the founder of SolidBox, was looking for a utility player that he could rely on, and he was a good friend of mine. And then I just kind of fell in love with CAD along the way and learned how to do it, and have since, gone through the ranks of the different certifications for SolidWorks. Got the CSWA after a few attempts, and then thankfully passed the CSWP a little while later with with fewer attempts, and it took me to take the CSWA, and then got through the specialty certifications that are prerequisites for the expert level, and then just back in April, I think it was April, passed the CSWE exam.
Nice.
Yeah.
Wow. So
yeah.
that's like a really interesting route. I mean, one of the things that I'm so thankful for this show for is allowing me to meet people who do kind of take these roundabout ways. Like another guest that we've had on the show before, Leonard Tyndall, he started out in theater.
Oh, wow.
And then like made his way around into the world of CAD, and now he's like a CAD and PDM expert, and he does this really cool series called Tips from the Train, where he does tips like every day. And
yeah,
it sounds like you kind of took another like a very strange route to end up ultimately in CAD. I think all roads just lead to CAD, right? But
yeah.
But so you said you started out in journalism, right?
Yeah.
And then ended up in e-commerce, and then made your way through into CAD.
Yeah. It was, and even I really haven't used my journalism degree in the traditional sense. I graduated in 2005, and right at the point where all news kind of started going online, and it became pretty hard to make a decent living working for newspapers. So,
Okay.
but I definitely use my writing skills, in my current job with SolidBox. So we do a lot of training content, and I write most of the scripts for that. We've done a lot of work for Solid Professor, including this GD&T, the GD&T courses that we've done for Solid Professor, which my presentation today is kind of based off of.
Okay.
And
so
yeah.
So you've put together a class specifically on GD&T.
Yeah. We've actually done 3. It's a series of 4 courses. We've completed 3 of them so far, and we're currently underway on the 4th one. The first one is more of a foundation, so it's for most people taking the course, it'll be like a review of standard tolerancing and dimensioning, and then with the second course, it's an intro into geometric dimensioning and tolerancing, which, for anyone that doesn't know, that's what GD&T stands for.
What does it stand for?
And geometric dimensioning and tolerancing.
Okay.
And
you
go
said
ahead.
That these courses that you've put together, are they available today at Solid Professor?
Yeah, solidprofessor.com, and they're the first 3 courses are available right now on their website.
Okay.
And I believe you can preview the first several videos of each course, for free. But then also Solid Professor has a subscription model that's, well worth it. They've got a really comprehensive library for CAD users.
Okay. So, and you said that this course, there's 4 sections to this course?
Yeah. 3 have been completed so far and are up on the Solid Professor site, and we're working on the 4th right now.
Okay. So why would someone who's using SolidWorks, who understands like the basics of how to draw a 3D model and how to create a drawing, why would they need GD&T? What does GD&T get you beyond just regular dimensions? Like none of my prints use GD&T, right?
Yeah. So the way I like to describe it is GD&T increases the vocabulary a designer has when conveying design intent to manufacturing. So with using standard tolerances, say you care about how flat a face is on one of your parts, you would have to use just, plus or minus tolerances for the thickness, of that, or whatever dimension is driving the location of that face. But it's causing you to be more strict than you might need to be if all you really care about is how flat that face is, as opposed to how much material is behind the face. So using GD&T, you can just it results in fewer scrap parts because you're conveying what you actually care about with the design intent, and it also just does a better job of making sure that your design intent is preserved through the manufacturing process.
Okay. All right. So, yeah, I think I might end up needing to see an example of this at some point.
Yeah.
Because, I kind of get what you're saying. I mean, when you're doing traditional dimensioning, for example, you're really only specifying I guess you're really only specifying in two directions, right? Like whatever that
you're
showing you.
Kind of specifying in XYZ coordinates is kind of what it works out to.
Okay.
But when you're looking at a 2D drawing, it is just two of those dimensions or two of those directions at a time.
Now, when you do GD&T, is this something that most machinists are aware of? Are they able to read it? Does it need to go into any type of post-processing? Like, are there actual machines that can read it? Maybe I know it was two different questions. Let me start out with the first question.
Right.
So, generally speaking, do machinists understand what it means to interpret a drawing that utilizes GD&T?
Yeah, I mean, I can't guarantee every machine shop will know it, but it's been around for decades at this point. And it's, the ASME Y14.5 standard is that's the Bible of GD&T. The most recent version being released in 2018. So whether every machine shop knows it or not, everyone should know it at least, or it's not unreasonable to expect them to know it.
Okay. All right.
And then as far as how it's inspected, that can vary on the based on what type of tolerance you're using. So a lot of things can be inspected, just with traditional like measuring tape and stuff like that. But there also are a lot of GD&T tolerances that require some more advanced like advanced tools like a CMM or a laser scanner.
Yeah, that's what I was going to ask
knowing
you.
Like
you mentioned one of the types of GD&T might be like flatness,
Yeah.
And so that's what I was going to ask you. Would you use like a ferro arm on that, a CMM? Would you use laser scanner to ensure that it is in fact flat and not like a wavy surface from the machining process?
Right. Yeah. So it just kind of depends on how strict your tolerance is. So if it's a super tight tolerance, then it might require something like a CMM to ensure that it's within tolerance. If it's a looser tolerance, you might be able to make a functional gauge that determines, how flat it is. Or in the case of flatness, you might be able to just put it on a granite inspection block and make sure that it doesn't rock around too much. It just depends on how tight that tolerance is, what tools you'll need in some cases.
Gotcha. Maybe you could give us just one more example before we take a look at the answers. Maybe just one more example of where traditional dimensioning and tolerancing might fall short. You might not be able to convey something, or that you would be able to convey with GD&T, and how that could help the machining and the manufacturing teams.
Yeah. So another cool thing about GD&T is it allows you to create what are called bonus tolerances. So with GD&T, take the example of a hole. So you have MMC, which stands for maximum material condition.
Okay.
And you have LMC, which stands for least material condition. So for a hole, MMC would be when that hole is as small as it's allowed to be, because that's when there's the maximum amount of material left on that part.
Okay.
And LMC would be the largest the hole is allowed to be.
Okay. That's interesting.
So
that would be different if it was a peg?
Yeah, so for a peg that goes through that hole, MMC would be the largest the peg is allowed to be, because that's when the peg is the largest.
Right.
And LMC would be the smallest it's allowed to be, because that's when there's the least amount of material. So the easiest way is just remember what MMC and LMC stand for: maximum material, least material. And then you can work out the difference between how that applies to a void or an extrusion,
And that's in that scenario, is that because the peg could, this kind of reminds me like of tolerance stacks. Like the peg could have a tolerance of ±5, the hole could have a tolerance of ±5, but if they're both in the extreme, in like the worst possible condition, the peg might not even fit in the hole.
Yeah, so when a peg is at MMC, that's when it's the least forgiving. That's when it has the least amount of room, right?
Right.
And the same goes for the hole. When the hole is at MMC, that's when there's the least amount of room. So even though we're talking about
the peg
even though we're talking about a
maximum,
smaller,
right? Yeah.
Yeah.
The peg would be maximum. The
so
hole
when
would be
both are at MMC, that's when you have the least amount of room.
Okay.
But that's why MMC is a smaller hole or a larger peg. It still results in a less forgiving condition. And so you can specify in your tolerances like an MMC modifier, meaning this tolerance applies when the feature is produced in its least forgiving, form. But when you, so for a hole being the smallest, but if the hole is larger than MMC, so if it's, normal, the nominal dimension, or if it's at LMC, it's obviously more forgiving. And you can build, if you add that MMC modifier, you're building in that bonus tolerance, allowing for, taking advantage of that forgiveness.
Got it. And I guess what I'm wondering is, just listening to you describe this, it almost sounds like in those situations, like if it was just a nominal tolerance, the inspection team might say this part's scrap. But it's almost like with GD&T, you can be a little more forgiving in those directions and actually avoid scrapping certain parts. Is that correct? Am I understanding that correct?
Yeah. You can, it just results in fewer scrap parts if you're using it correctly, because you're preserving the design intent still, and that's what you really care about.
Okay. Cool. Yeah. All right. Well, I'm excited to see some examples of this. I think what I'm going to do is I'm going to flip back to the to us together looking at the PowerPoint here, and I think we're going to just take a look at some of these answers that came in, because I saw that not only did we get some good answers that came in, but we also had some comments here about GD&T. So one of these was, I wish I had learned GD&T in college 25 years ago, but I've had barely any opportunity to use it. I had to learn about GD&T in college 25 years ago, but I've had barely any opportunity to use it in real life. So that's like a comment from Chris. And then we kind of have the opposite comment from Victor, who says, GD&T is the biggest thing I wish I had learned in university. Use it all the time in my current field. So I guess that's kind of another thing to keep in mind, is that it may just depend on, what type of work you're doing and what the manufacturing process looks like, how important this is to you.
Yeah.
So, and then I guess, for somebody like Victor or anybody else who's out there, while you were talking, I showed the Solid Professor course. If people want to learn more about GD&T, like I saw Eric said, what's the best resource for GD&T? So maybe aside from the course, what are some other things you might recommend to people who want to at least get their feet wet?
Yeah. So we also do live training, and it can be, virtual or in person. We recently trained some the manufacturing people at Hill Air Force Base here in Utah a few weeks ago. Or I'm sorry, not a few weeks ago. It was a few months ago at this point. But yeah, Chris Castle and I went up there and did that live and in person. But we can also do the same class within, virtually as well, via Zoom. And it's great because it allows for a lot of in-person interaction, and like GD&T, some aspects of GD&T can be kind of hard to grasp, and having that in-person interaction to focus more on parts that one or more people in the class might not have their head around yet, can really help. And then of course there's the Solid Professor courses.
Yeah, I mean, I think that's another thing too, is like each person learns a little bit differently. They kind of have their optimal solution. Like for some people, it's actually better to do the self-paced stuff because it just gives them the opportunity to squeeze it in as they have time. Other people, that just doesn't work. Like I've taken plenty of self-paced courses where either I just didn't finish the course, or when I was done, I kind of was like, I don't know if I really get this yet. Like I actually prefer the in-person stuff personally, but it's just different for everyone. I see Jason here said GD&T is part assembly manufacturing dependent, so think of something to make and determine the required tolerances. So I think that's like kind of in line with what we were saying a moment ago too. It kind of depends on how the manufacturing process works and what tools they have.
Right. Yep.
AM Carbotech says GD&T is big in aerospace industry. Do you and Jason seconds that. He says it's critical in aerospace, co-signs it. So do you find that to be the case, and are there specific industries where like it's just like absolute must, like if you're going to be in this industry you need to know GD&T?
Yeah, I mean that makes sense if you think about the tools, because inspecting some of the GD&T tolerance does require some advanced equipment. So you would expect in aerospace manufacturing that they've got the equipment to do that, like CMMs and laser scanners and all that stuff.
Right.
And obviously it's critical stuff we're talking about that can result in a plane coming out of the air if it isn't manufactured correctly. Yeah,
the criticality, I'm sure will dictate whether or not you need to use these kind of like more it's really a more advanced tool, right, for tolerancing. I mean, that's kind of
right.
I know it's a blunt way of saying it, but it's like this is taking the whole idea of like plus minus tolerancing and even tol stacks to the next level.
Yeah.
It's really a more advanced expansion of your toolkit.
Yeah.
All right, cool. Well, I'm reading a lot of comments here. I'm just going to roll back. I think it's time for us to take a look at our first answer here, answer number 1. So what did you think about this part here, Chris? Do you think this is one that you would have been able to model up?
Yeah, actually, it's kind of similar to my favorite SolidWorks Model Mania part, which was like the knob from a dryer or something.
Okay. Cool.
But yeah,
I got to figure out what year that was.
I have an idea of how it would do.
If you're in the chat and you know what year model that was for Model Mania, let us know, and we'll give a shout out to, of course, the great Mark Schneider, who was on the show it feels like it was just yesterday, but I think it was actually like a couple of months ago. But huge shout out to Mark Schneider, the true godfather of Model Mania. All right, let's take a look here through the chat and see what kind of answers we got. I did have my production team. Shout out to my production team. Let me know that my volume was a little low. So please let me know if my audio from my microphone is a little low or anything, and we will definitely get that resolved. And thank you very much to the production team. All right, first answer came in from Gerben, our current champion of the TooTallToby tournament series. 28 grams. Gerben, I can tell you that is not correct because the precision is not correct. It's got to be... we're looking for 4 significant digits. What is the mass of this part in XX.XX? So hopefully we'll see if he revised it a little bit later on down the chain here. Victor coming in 29.17, revising to 28.25. You are allowed to revise your answers in this challenge. Your final answer will be the one that we'll accept. Bjorn says 27.42, so we're seeing quite a bit of variety here. But Tom Smith kind of confirming 28.25 and even giving Victor a preemptive GG in the chat. Let's see here. Gerben says 28.25. Let's see here. So he did revise. And Maeli says 28.25. Nice. 27.86 from Nico. 28.25 from Bjorn. So it looks like we're seeing 28.25 coming through here pretty consistently. Nico coming in 28.25. Nicely done, Nico. Pedro coming in 28.25. We got AM Carbonex coming in 25.39. Thomas coming in 27.02. Chris Castle. Nice, Chris. 27.29. I feel like I'm seeing that number a lot too, so I wonder which one it's going to be. 28.23 here from Omri. Nice job, Omri. Let's see here. What else we got? 27.29. Again, another one. Changing answer. 27.29. Let's see here. We got some shout outs here to Mark Schneider, from Chris Castle to Mark Schneider. Mark Schneider is the greatest of all time. And it was Model Mania 2006. There you go. So both Todd and Chris Castle confirming. And side flange makes trouble. Any advice on that side flange? We'll take a look at, maybe we can take a look at this one in a future episode, Omri, and we can talk about that. All right. And Tim Kraft is saying GD&T is critical for crucial for assemblies. So yeah, I could imagine that, that's like the whole theory of tol stacks, right? When you have multiple parts that need to fit together, each tolerance can make things worse and worse and worse. If you happen to, tolerance the wrong way, if you will. Okay, so let's find out what the answer is to this one. The answer is 28.25. 28.25. So I think our winner for that first one was Victor, if I remember correctly. Yep, here he is, Victor. So congratulations, Victor. GG. If you guys could all give Victor a GG in the chat, I will take a sip of my second tasty beverage of the day. This time we're mixing it up a little. We're going with some grapefruit sparkling water. Pamplemousse, if you're fancy, if you're rich. But for me, it's just Kirkland's Best. Kirkland, if you're looking to sponsor any live streams, you can reach out to me on the side with your seltzer water. All right, GG to Victor. GG. And let's get on here. Let's go on to the next challenge. So I'm going to flip over to my full screen here so you guys can see this and grab a screen capture. And we are going to go to challenge number 2. And this is going to go live here in 3, 2, 1, go. So for challenge number 2, you can see that this is a part in inches. I know you guys love inches. You guys always are reaching out to me. I get so many messages from people saying, we love inches. We need more models in inches. So I think inches is making a comeback. That's usually what I hear. I know that we're on a little bit of a downswing right now. Not too many countries using it, but you never know. You know, this could be like the comeback kid. So inches is going to be the next big controversy, I think. The next big news cycle is going to be all about inches taking over. Yep. So what's the mass of this part in 0.xxx pounds? This is in IPS. The material is plain carbon steel, and we're looking at this thing in 7,800 kilograms per cubic meter. And please take a screen capture of this. I'm going to take one more sip of my drink. Eric in the chat says, no inches.
The countries that walked on the moon, they're the ones that use inches, right?
There we go. That's what matters. That's going to be the next revolution, I think. All right, here we go. No one's going to get to the right spot, to the meetup spot for the revolution, because they're going to be so confused by like 16ths and 30 seconds and stuff. All right, I hope that's enough time for you guys to grab that print. I'm going to flip back to my special guest here, Chris. We're going to be looking at the screen together. NASA uses millimeters, so Barry is saying... No, NASA uses millimeters. So, what do you think about this part, Chris? Think this one's good?
Yeah.
Where do you think you would start if you were challenged to model this thing? I know people are working on it, but they've had enough time to get started. So, where do you think you would start?
I'd probably just extrude. At first, you know, I see like a drawer handle and I think sweep, but in looking at it a little more closely, like it looks like you could just, you know, do an extrusion on the what I would see as the front plane if the bottom left is the front view.
Yep.
And then add some fillets to it. And go from there.
Yeah, cool. I think that's probably a pretty good start to this thing. Let's see what the chat comes up with on this one, but I think that's probably what I would do too.
Yeah.
I like how I say that's probably what I would do. Like
as if you haven't modeled.
I don't have any idea. Yeah.
Yeah.
All right, cool. Well, I think what I'm going to do, if it's all right with you, is I'm going to ask you to share your screen. And I think you actually already have it shared here, so let me just bring that up.
Cool.
And what I'm going to do is, okay, I see we got this leather punch model here. I think that's what it is, if I'm not mistaken. I've worked with my fair share of
You've seen it before. You can read
So,
you can read the file name.
Yeah. So, and I was able to read the file name as well. Yep. So, when it comes to this model, this model, how would GD&T work in a model like this?
Yeah. So this is, I pulled this up because I had this in mind when I was describing, you know, how you could use flatness.
Okay.
So, say you really care about how flat this face is because that's how this punch is going to be, you know, bolted to a table. Mm-hmm. With standard, you know, plus or minus kind of tolerances, you can control that by saying the height here, you know, say 14 millimeters plus or minus 0.05 of a millimeter. So that would take care of the flatness, but then you're really creating a super strict tolerance on the thickness of this base, which you might not really care about. You know, you just care that there's enough material there. So maybe really for the thickness, what would be good enough is plus or minus 2 millimeters. but now you don't have a way of describing how flat you want it to be. Well, with GD&T, you do.
Yeah, I mean, if there was a dimension, let's say I'm looking at this thing from a front view, and the width is defined as, whatever it is. Let's say it's 15 millimeters. Where would you measure that from during inspection? Would you have to measure it basically from everywhere?
Are you talking about this height here?
Mm-hmm.
Yeah, I mean, you would just make sure that each point is no more than or within the tolerance given on the print.
Okay.
Yeah.
Okay. But flatness is a little different?
Yeah, so flatness is a little different. So here I've got a drawing with that flatness call out applied to that surface. So so here we've got a chart showing all the different symbols. There are 14, and actually 2 of these, concentricity and symmetry, were done away with in 2018. But flatness, the symbol is this parallelogram. And so here on this print, you've got a call out saying this surface has to be flat within 0.1 millimeters. So what that looks like, if we go back to the model, is now I've got 2 planes here that are 0.1 millimeters apart.
Okay.
So if I go back to this view and then zoom way in, this is obviously between those 2 planes because it's, just how I modeled it. It's perfectly flat. But say, or cut a little wavy like this. If we zoom out, we can see that's, a terrible cut there.
Okay.
And it's, not between those 2 planes. It's kind of weaving in and out.
Okay.
So that's what that flatness tolerance zone would look like, that of 0.1 millimeters. It's the distance that each point on the face would have to be within 2 planes that are parallel to each other that are 0.1 millimeter apart.
Okay. So when it says that, when it has that 0.1 millimeter on the flatness symbol in the drawing, that means that it's really 0.2. Right, because it's
it's a total tolerance.
It's total, okay. So it's like a half.
Yeah.
Okay.
And that's the same for every GD&T tolerance. It's always total tolerance.
Okay, got it.
Yep.
So is there a scenario where a traditional plus minus tolerance would yield a pass during the inspection process, but a geometric tolerance would yield a fail, or vice versa? Like, is there a spot where you look at it with like the plus minus tolerance and you'd be like, oh, this part failed inspection, but with the GD&T, it actually would pass? Like, for example,
in this scenario?
Yeah, I mean, in this scenario, what if the person doing the inspection just measured that part and happened to measure it at a location on the wave where the thickness was correct?
Yeah, so in this scenario, it would need to be... It allows you to make your standard tolerance a lot larger. So, since you have the GD&T tolerance taking care of the flatness, now you can have a more generous standard tolerance. So instead of it being 14 plus or minus 0.05 of a millimeter, it could be 14 plus or minus 2, which there are plenty. And this would probably pass that inspection, the plus or minus 2 millimeters. But the GD&T is now acting as a refinement of that tolerance, saying how flat this face has to be. So it would fail inspection of the flatness.
Got it.
Which
that makes sense.
That's what you really care about. Like if you're want this to be, bolted to a rigid table, you don't want all that space there. So that's how it's preserving that design intent in this case.
So if it was 14 plus or minus, let's say 0.1, then every single measurement from the top surface to the bottom surface would have to be within that plus or minus 0.1. But if it's like 14 plus or minus 2 millimeters, let's say it's 15 millimeters thick, generally speaking, then after you figure out that that's within the tolerance, then you proceed to examine the flatness.
Inspecting the flatness,
and that would be relative to 15 millimeters.
And the nice thing is, now say it's 15 millimeters but you realize it's not flat enough. Well, your tolerance was 14 plus or minus 2. You have some room to face it again and get it flat enough and still be within your your standard size tolerance,
and not have to scrap the whole part,
and hit that flatness tolerance without scrapping the part,
and not have to scrap the part. Yeah,
and cool. you still end up with a part that meets the design intent.
That's cool, man. I didn't get that before. You're a good teacher.
Yep. Good, thanks.
Yeah, that's good. It clicked right when you gave that final example. I was like, okay, I got it.
Yeah.
So you showed one example there on the print of that flatness geometric tolerance. Do you have any other examples of geometric tolerance on a drawing?
So going back to our chart here, so flatness is a form tolerance, and none of the form tolerances use. They're all independent of datums, and you'll learn what that means here in a second when I talk about an example that uses a datum. So perpendicularity, which a lot of these are pretty easy to remember what they mean, just because they're the symbols are descriptive.
Mm-hmm.
And perpendicularity, you got two perpendicular lines, so that's a really easy one to remember.
Okay.
Perpendicularity does require datums. Think perpendicular to what?
Right.
Whereas flatness, that just when you know the meaning of the word flatness, it's understandable why it doesn't use a datum.
And what is a datum?
Yeah, so a datum is a reference. So when I say perpendicular to what is the datum. So
okay.
So here we've got a hole, and for this hole, we would say, here, let me hide that bolt there,
mm-hmm.
And hide this. Oh, I hid too much. Here, I'll just open the actual part. There we go. Okay, so now we're at the part level.
Okay.
And let me hide this. Turn off.
You gotta hold shift. Shift is the magic key there when you're picking transparent geometry.
Oh.
Hold shift, it'll let you pick what's in the
There you go.
Yeah.
Except then tab doesn't work when I do that.
Yeah. Yeah.
I'm used to using tab to hide stuff. There we go. All right, so we've got it hidden. And now we're talking about this hole. And you've got the axis of the hole shown here.
Okay.
And if we go back to the call out, which I have here. So
okay, wait, I haven't seen this yet. This is a new print.
Yeah, you haven't seen this yet.
New print, okay.
New print. So what this is saying is this hole has to be perpendicular to datum A, which we see in this front view. Datum A is the bottom face of the block.
Okay.
Within a diameter of 0.3 millimeters. And then this is the MMC modifier. I won't get into that just yet. But I'll cover that in a second.
What? But how is it within? Wait, but the diameter of the hole is 4.5. So how is it 0.3 is the diameter? I don't get.
So
what that
0.3. What's funny about GD&T is it doesn't use angles for calling out perpendicularity. So it's not perpendicular plus or minus half a degree or whatever, like you might expect.
Mm-hmm.
It's using a diameter, and so that surface that I was struggling to hide is actually the illustration of that.
Okay.
So let's show that again, and so see this surface here.
Yeah.
This is like a 0.3 millimeter cylinder.
Okay.
There we go. So yeah, if I hover over that, you can see it's 0.3 millimeters in diameter, and it's saying that the axis of that hole has to be within that cylinder. This is a perfectly perpendicular hole, so of course it's in there. Go ahead.
Yeah, I was just gonna ask what you mean. What do you mean by that? The axis of the hole needs to be in there.
So here's what the hole might look like if it were tilted. I'll turn on this section view now so we can get a better look at it. And okay, so now you can see that hole was drilled at an angle.
Okay.
And we can see the axis of that hole is also angled right now. But it is still within that 0.3 millimeter cylinder. Let me Let me
Oh,
just
that's interesting. Okay,
Yeah.
so you create, like in this case, you created an actual surface extrude, but you.
Yeah, just for the purposes of illustration. Yeah.
Okay,
To
so
show
you
that.
envision a 3 millimeter diameter circle, and as long as the axis starts inside that and ends inside that, and that theoretical cylinder is true perpendicular, then you're
Right.
within the geometric tolerance.
Yeah, and
Okay.
what's cool is
Interesting.
that adjusts based on the so with an angle, if we used an angle
Mhm.
for that call out, it would need to be adjusted based on the thickness of the plate, right?
Right.
But since we're not using an angle, we're using a diameter. Say if it's shorter, let's see. Here we go. If it's shorter, here's a tall or a normal size version of it.
Mhm.
If it's shorter, you notice how the hole is slanted a lot more.
Yeah.
Like to a greater angle.
Yep.
But that is still within the same. It would still fit within the same tolerance.
Oh, interesting.
And
Okay.
here, let me
because
let
the
me
tolerance is not
unsuppress
an
that.
angle; it's like it's
It's a diameter.
It's just
And
within
here,
that diameter.
if I show that surface again, and then let's show the axis of this hole now. See, it's right within there,
Yeah. that's
even though it's still the
interesting.
same tolerance we're talking about.
Okay.
Yeah.
Cool. Well, I'll tell you what. I want to keep talking about this, but I want to make sure that the chat has enough time to do the final challenge. So I'm gonna flip back to my screen here just for a minute and keep you on here on your webcam. But let's take a look here. This is pretty interesting. I'm gonna get back into this discussion of GD&T, but let's just take a look here real quick and see what our answer was to this handle. We want to make a guess real quick or anything? It needs to be 0.xxx pounds. What do you think it is?
I'm gonna say 1.3 pounds.
1.3. Okay.
I have no idea.
All right. I'm gonna say that's not correct, but I do
Okay.
appreciate that. That's good. Good guess. Let's take a look at the chat here and see. The only reason I'm saying it's not correct is because it's just outside the significant digits. So let's see what the chat came up with here.
1.30.
So Gerben came in 0.918. Always solid, Gerben. That's possibly the correct answer. I'm not going to say yet. Victor, 0.918 as well. And giving a preemptive GG to Gerben. Tom Smith, old friend of the show. What's up, Tom? Special shout out for Tom. 0.282 and then revised to 0.879. Put the density in wrong. So there you go. Bjorn coming in 0.918 and my Melee coming in 0.918. Tom Smith revising once again. Missed the inside radius, was different. A little gotcha there. Chris Castle coming in 0.918. Nice job, Chris. Let's see here. AM Carbetics coming in 0.89. Mad Cannon, I love that screen name. Mad Cannon coming in 0.918. Nicely done. And Thomas Dunn coming in here 0.918. Some discussion going on here in the chat about the about GD&T that we will maybe double back to. AM Carbetics coming revising to 0.892. Pedro coming in 0.918. Nicely done. Omri coming in 0.918 as well. And the correct answer is 0.918. So very nicely done, everyone. And GG to Gerben coming in with the very first answer. Nicely done. If you guys want to give Gerben a GG in the chat, very nicely done. Very, very nicely done. And very fast as well. I saw that one come in, I think like less than 2 minutes after we started talking about it. So Gerben is a speed demon for sure. And he is currently the reigning champion of the TooTallToby tournament, but we're going to have another one soon, Gerben, and you're going to have to defend that title. And let's take a look here at our final challenge. Chris Castle in the chat says, I can't believe I've gone this many years without knowing about the shift toggle for selecting transparent bodies. Yeah, that's a good one. Shift is like a magic key. There's lots of times when shift can help you out, but that's one of the biggest ones is the way the logic works in the software is if there's something behind a transparent body, you can use shift and select the thing that's in the foreground. If there's nothing behind it, then it just works the way it normally does, but that's definitely a good one. Maybe we'll make a power move on that. I feel like I might have already made a power move on that, but I think it's time to revisit some of the old power moves. And
Yeah, that's a good one. I like it.
Spice them up a little bit, right, for 2022. That could be my summer 2022 project. All right, here we go. Let's take a look here, guys. Final challenge coming at you in 3, 2, 1, go. So this one is in MMGS, 1060 alloy, 2,700 kilograms per cubic meter. And this one is, we're looking for this answer in XXXX grams. Taking a final sip of my drink here. Hope you guys know the drill right now. Eric says, I like the music. Good, Eric. I'm glad you like it, man. Thank you very much. I curated this playlist on my own from a paid library. Let's see here. What is the mass of this part? XXXX. Hope you guys have enough time. Use Windows snipping tool. Use Snagit. Use MW Snap. I'm going to flip back to our special guest here. This is probably the easiest of the three, but I just like this part. I decided to bore out the bottom here to make it manufacturable.
Nice.
Yeah. I should have a better angle shot so you can see this 25 is going through. This usually I would take a little more care to show that, but there is a 25 through in the middle here. You guys want to make sure you're aware of. Should have put some GD&T on this one too. I'm not sure if GD&T would be conducive to a speed modeling challenge where you're trying to come up with the mass.
Yeah, well, you know what you could do is you could add some GD&T callouts and then specify that everything be modeled at, MMC or whatever.
Oh, yeah. So maybe we should talk about that. I think we were getting into that.
So it's testing whether they can read the call out or.
So yeah, I mean, I think on your if we go back to your print, your 2D print. So I'm gonna flip back to your screen. And then,
yeah.
Like you got the M there. Is that minimum?
So strike the word minimum from your vocabulary.
Okay.
Because the M in MMC is maximum, and then the opposite is least. So you'll confuse yourself if you think of minimum material condition. So then maximum material condition, least material condition.
When we're looking at perpendicularity, what does the maximum material condition mean? Because I would think right. that would have to do with like the diameter of the hole.
It does. So think about if the hole is as small as it's allowed to be, which in this case we've got our plus minus tolerances here. So the smallest it's allowed to be would be 4.3 millimeters. And you have a bolt with a major diameter of 4 millimeters going through that hole. Then you have the least amount of forgiveness there, when it's at maximum material condition. I mean, that's always the case. MMC is always when it's going to be the smallest.
Okay.
And when it's going to be the least forgiving, consequently.
Right.
For a hole. So if we, I'm hitting Control Tab, not Alt Tab. Okay. So if we go back to the block with the hole, or actually, let me go back to the, there we go, back to the assembly here with our bolt. All right, and I've got a few, all right, so here we've got it at MMC, meaning that's now a 4.3 millimeter hole. And you can see there's not a whole lot of room around there. And if I tilt it, now it's like at the edge of that perpendicularity tolerance I gave it. So you can see it's like almost touching the bolt, but it's not quite touching the bolt. I can see in interference detection, it's still good.
Right.
But at LMC, we still have a lot of room around it, right? Even though it's using the same tolerance, because that hole's a lot bigger. So if that modifier weren't there, if there were no MMC on the if the symbol were not here, that would still be all the tolerance I get. This would be at the edge of the tolerance. But since that symbol is there, it's saying this tolerance applies at MMC, and you get a bonus tolerance as you depart from MMC. So the larger the hole is, the looser that tolerance becomes. So this is 4.8 millimeters, and it's around, going around a 4mm bolt. So really, I could change this to, I did this hole as a sweep, and this is dimensioning in the X direction, the start and the end of the sweep. So I could change this to 0.8mm now. Let me just change it for this configuration. And then hit Control Q to rebuild. And yeah, see that works out. It's obviously a much more drastic angle there. But if I go to back to interference detection, still no interference. So adding that material conditions modifier allows you to take advantage of that bonus tolerance you get when you're departing from MMC towards LMC.
Yeah, I mean, I remember before we started live streaming, you said that when you learn GD&T, it's kind of like you're expanding your vocabulary.
Yeah,
and I think that this is kind of a good example of that, because how would you would need to use so much to define what you just showed there with traditional tolerances or traditional dimensioning, specifically with traditional tolerancing. And keep in mind that we're not just going in two directions, right? We're going three directions. So like it's like or at least like a cylindrical effect here to calculate this angle. So I think that's a great way of saying is that when you learn GD&T, you're able to, it's a much more elegant way of describing to the machining and inspection team what passes and what fails. And you don't have to use all these clumsy words, like, well, the thing is, if you put a bolt in here, you're gonna and if the hole's bigger, then you're gonna have a little bit more. The angle could be a little more, but if the hole's smaller, then the angle needs to be smaller, and you're able just to convey that all in that, basically that one little frame, and then with data. Yeah.
It took me 5 minutes to explain that, but all that stuff that I explained is all right here.
So I guess that the question is, I think we've kind of answered this question, but what are the next steps for somebody who wants to learn this, who needs to learn this? And it sounds like, one thing that I've learned from this is that if I need to get up and running with GD&T, one resource is Solid Professor, right?
Yeah, Solid Professor for sure. And that's great for, it's all pre-recorded content. But if that's a little more difficult for you to, you or your team to stay engaged following that pre-recorded content, then definitely reach out to us and we can, arrange a live class. Chris.smith@mysolidbox.com is my email.
Yeah, I just put that up on the screen. I put us up next to one another. So Chris.smith@mysolidbox.com. You guys can see that in the lower right corner there. And that's where they can reach out to you if they want to do custom training on this topic.
Yeah.
That's awesome, man. Well, this has been great. This has been very, very insightful. Well, I guess we'll go into bonus time here, go into overtime, maybe for 2 more minutes while people are finishing up their answers. Is there anything else that you've discovered in your journey into GD&T that you think is kind of interesting, or fringe cases or anything?
Sure.
Kind of unique you want to show?
Yeah, I've got a little more esoteric example.
Okay. This is going to be the final 2-minute example.
All right. So one of the callouts you got is straightness, which is just a straight line. And straightness of an axis is really easy to understand. It's, how straight that axis is. It's not, your hole doesn't end up like a banana or whatever. But there's also straightness of a surface, which is a little harder to wrap your head around. It can be thought of as flatness in one direction. So if flatness is, in both the X and the Y direction, straightness would be you pick the X or the Y.
Okay.
And I had a hard time, explaining this or visualizing it. So I came up with this model to do that. So what we have here is a twisted plate. I modeled it as a loft, with 33 degrees of twist between the two profiles. It also could be done as a sweep using that specified twist value. But in any case, what it's representing is a plate that's been twisted.
Okay.
So this is perfectly straight in the X direction, meaning every line that's parallel to this edge that I have highlighted here is perfectly straight.
How do you know that?
I'll show you.
Okay.
It's not straight in the Y direction, so that would be parallel to this direction.
Okay.
And we can illustrate that. I've got this sketch that I've already prepared here. So each of these lines is, connected to these edges, and it's and when I hover over them, they show up as lines. You see that line symbol next to my cursor. So SolidWorks is recognizing those as lines. And I can go in and edit this sketch, and I'll take this line. I already did it to that line. I'll take this line, this face, and add a tangent relation between those. And I don't get an error because it is actually tangent to that face.
Okay. So that face at that location is perfectly straight.
Yeah, it's perfectly straight in this X direction.
Okay.
But it's not in the Y direction. So to illustrate that, I have all these intersection curves that I created. And how I did that was, I got a bunch of planes that are all parallel to the right plane.
Okay.
And then I made intersection curves between those planes and this face. And if I hover over them, now I got a spline symbol that shows up. It's kind of hard to tell with the naked eye. Like, they look like they could be lines, but SolidWorks is recognizing them as splines. And if I do another 3D sketch and connect the endpoints of these intersection curves with lines, which I'm showing in red. Okay. I can zoom way in and see those lines aren't right on the intersection curves because these are splines and these are lines.
Wow. So straightness is so straightness, that's what it's called. Straightness is another type of geometric tolerance thing.
Yeah, straightness of a surface is what that's demonstrating. But there's also axial straightness, which is would be like how straight a cylinder is, for example. That's a little easy to understand.
Yeah.
Think of like an arrow, whether it's bent or not. That would be straightness, axial straightness. But this is straightness of a surface.
I would think that
I'm showing here.
Axial straightness would probably come up more often than this one.
Yeah, it is more common for sure.
That's cool though, man. I like seeing those kind of fringe cases. I think that they're always like a little exciting, and it kind of gets you thinking outside the box a little bit. Cool. Well, I'm going to go back to my screen here, and we're going to take a look at our final answer for answer number 3 here for today's challenges. And let's bring up the chat, and we'll see what the chat came up with here for this final answer. So this one was called bracket. And let's see here. What do we got here for our answer? So we got Gerben coming in 1318, then revising to 1297. Tom Smith coming in 1310. Tom Smith, former Model Mania multi-year champion, old friend of the show. Victor coming in here with 1297. I keep saying this name wrong. I'm so sorry. Meili. I think I said it 5 different ways on this live stream. Meili coming in with 1297. Nicely done. Tom Smith revising to 1297 and giving Victor a GG and giving, I guess, in turn, Gerben a GG as well. We got, let's see here. Oh, wait, Gerben got it. GG to Gerben. Okay, good. Let's see here. 1297 from Bjorn. Nicely done. AM Carbetics coming in 1461. Nicely done. Chris Castle, 1297. Very nicely done, Chris. Pedro coming in 1310. Nicely done. Rigoberto Ramirez saying, what's up, Toby? What's up, Rigoberto? Great seeing you in here. And let's see here. Jason saying modal math. Nice. And we got, let's see.
Model math, I think.
Model math. Omri coming in 1261. Thomas Dunn, 1294, revising to 1297. Omri going to 1248. Eric coming in 1297. Thomas saying can't type. And Pedro, once again, 1297. So very nicely done to everyone who competed today. Let's take a look at the final answer. The correct answer is 1297. So very nicely done. And I want to say, of course, thank you to everyone in the chat, but especially give a GG to Gerben for once again taking it down. 2 contests this week. Nicely done, Gerben. I can tell you're getting ready for the tournament. So very nicely done. And final question came in here from Timothy Kraft. Says, anytime Chris Smith touch on max material symbol on a datum. So I guess max material, you got any thoughts on that? Anything real quick you want to sum up on that? Or is that something that maybe needs to be done?
I'm not quite sure that I understand Timothy's question. The last example, was using the max material condition on a call out that referenced the datum.
Okay.
But yeah, I think
Cool.
it would need some more context.
All right,
for that
cool.
question. I want to say I like anytime I can use a full round fillet, and
Nice.
so
Yeah.
I like that on this.
Yeah, so that's a good one on this print here, huh? So there we go. Cool. All right, well, I want to say, I know we went into overtime a little bit here. I want to thank everybody so much for sticking around, and we're going to be back, I guess maybe not next week, but congrats to our winners. Congrats to, who got the first one? Do you remember who got the first one? Was it Victor? Can't remember who got the first one. I think it was Victor.
I forget.
So congrats to our winners. I'm just confirming here. I think it was Victor. Let's see. Or was it Bjorn? Oh, crap. I can't remember what the first answer was. 28.25. Yeah, it was Victor. So congrats to Victor. Congrats to Gerben. And thanks so much to everybody for hanging out today. And, of course, thank you, Chris, for being our special guest today and teaching us all about the world of GD&T. Hopefully we'll get some people together here. If you guys enjoyed having Chris on the show and you want to learn more about GD&T, let us know in the chat or reach out to Chris, chris.smith@mysolidbox.com. And, of course, I want to thank everybody for tuning in. Don't forget, get out there and like and subscribe, share this channel, reshare the channel. We'll try and get some more people in here. And next week is 4th of July. I don't know if I'm going to be going live or not on 4th of July. Most of us are probably going to be celebrating on Sunday on the 3rd, so I might be around. I'm just going to kind of do an audible for next week. If I'm around, I'll live stream. If I'm not, I won't. But I'll let you guys know later on in the week. But other than that, I just want to say thanks so much. Thanks to our special guest. Thanks to the most amazing chat ever. We will stick around for a few minutes and answer any other questions you have in chat. But I want to wish everybody a great rest of your day, great rest of your week, and I'll see you guys in the next one.
Thanks, Toby.
Yep, thanks, Chris. You were awesome. See you, everybody.